Everyone knows the record. 11 days, 264 hours. A teenager did it in 1964, and it's been quoted ever since as the outer limit of the human machine. Here's the problem. He didn't actually do it, not the way you think. And the real answer to how long you could survive without sleep isn't 11 days. It's closer to a day and a half. Not because your body fails at hour 36, because of something far stranger. By hour 36, you've lost the one ability you'd need to know anything has failed at all. This is the countdown nobody runs. Honestly, let's run it. First, you need to understand what you're actually up against, because sleep is not what you think it is. Most people picture sleep as an off switch. The brain powers down, rests, powers back up. If that were true, skipping it would just mean running the machine a little longer between charges. But sleep isn't the brain switching off, it's the brain switching to a different job. While you're unconscious, fluid flushes through the spaces between your brain cells, clearing out the metabolic waste that builds up during every waking hour, including a protein called amyloid beta, the same protein associated with Alzheimer's disease. Brain scans have measured that waste rising after a single missed night. Sleep is a cleaning cycle, and it's a cycle that cannot run while the machine is on. So when you decide to stay awake, you're not skipping rest, you're cancelling maintenance. And the system that suffers first is the one reading this sentence. Hour 17. You've been awake since 7 in the morning. It's now midnight. You feel fine, a little heavy, nothing dramatic. You'd trust yourself to drive home. Here's what a famous experiment found when researchers actually measured people at this point. After 17 hours awake, performance on attention and reaction tasks matched someone with a blood alcohol level of 0.05%. That's several drinks. By 24 hours awake, it matched roughly 0.1%, over the legal driving limit almost everywhere on Earth. Think about what that means. A person who would never touch a car after 3 beers will get behind the wheel after a long day without a second thought. The impairment is comparable, but only one of them is illegal, and only one of them shows up on a roadside test. There is no breathalyzer for exhaustion, which is exactly why it kills so quietly. Hour 24, 1 full day. And now your brain does something you didn't authorize. It starts sleeping without you. They're called microsleeps, lapses lasting anywhere from a fraction of a second to 30 seconds, where parts of your brain simply drop offline. Your eyes can stay open. You can be mid-sentence, mid-highway, and you have no idea it happened because the part of you that would notice was the part that was asleep. It goes deeper than that. Researchers recording the brains of sleep-deprived animals found individual patches of cortex slipping into sleep-like waves while the animal was awake and moving around, and errors on tasks spiked at exactly those moments. Sleep doesn't wait for permission. Past a certain point, it takes the brain in pieces. Which means the entire premise of the challenge is broken. Nobody has ever gone 11 days without sleep. They've gone 11 days without consolidated sleep, while their brain stole it, seconds at a time, behind their back. You are not choosing whether to sleep, you are only choosing whether it happens safely. Hour 36, the trap springs. Because here's the cruelest part of the whole countdown, and the reason the honest survival window is so much shorter than the record. Your ability to judge your own impairment breaks before almost anything else. In one of the most important sleep studies ever run, researchers restricted healthy adults to 6 hours a night for 2 weeks. Objectively, their attention collapsed. By the end, they were performing at the level of people who'd been awake for 2 straight nights, but their own ratings of how sleepy they felt leveled off after just a few days. They felt slightly off. They were performing catastrophically. Sleep deprivation disables the instrument you'd use to measure sleep deprivation. The gauge fails first, so the person confidently saying, "I'm fine, I do this all the time," is the person whose self-assessment broke earliest. This is the turning point of the entire question. The survivable limit isn't when your body gives out, it's when you stop being able to tell that it has. And that line falls somewhere around a day and a half in. Right about the time something happens that convinces you of the exact opposite. Because around now, you suddenly feel better. Somewhere in the second night, many people hit a strange window of energy. Giddy, wired, sharp, or so it seems. It feels like proof you're built different, proof you're winning. It's a documented chemical effect, and psychiatry has known about it for decades. Keeping severely depressed patients awake all night is a real experimental treatment called wake therapy, and a large share of them improve within a single day, faster than any medication works. The catch is that the effect collapses after the next real sleep. So that euphoric second wind isn't evidence you're coping. It's your brain chemistry being bent so hard that it briefly works as an antidepressant. The high is a symptom, and what comes next is the price. Hour 48 to 72, days 2 and 3. The mind starts filling in things that aren't there. It begins small, movement at the edge of your vision, a shadow that reads as a cat, a hat that becomes a face. Reviews of sleep deprivation studies map a remarkably consistent sequence: perceptual distortions within the first day or two, true hallucinations often by the second or third night, and beyond that, disordered thinking and paranoid, delusional beliefs. By around day 3, the clinical picture can resemble acute psychosis. Not in fragile people, in healthy volunteers on a schedule. The one mercy is that it reverses. Sleep and the visions dissolve. It's one of the only psychotic states in medicine with a known cause and a known cure. But that mercy only applies if someone gets you to a bed. Because from the inside, by day 3, you're no longer equipped to make that call yourself. Which raises the question this whole video exists to answer. If you just kept going, past the hallucinations, past the record, would it actually kill you? Here's where the science gets genuinely strange. In the 1980s, researchers built an apparatus that could keep rats awake indefinitely. The rats died, reliably, in about 2 to 3 weeks. But when they examined the bodies, they couldn't find the cause. No single organ had failed. For decades, death by sleep deprivation was a documented fact with no mechanism. Then in 2020, a team at Harvard found something nobody expected. In sleep-deprived animals, lethal damage was accumulating not in the brain, but in the gut. Reactive oxygen molecules, cellular rust, building up in the intestines. And when they fed sleep-deprived animals antioxidants, they survived dramatically longer. Everyone assumes sleep loss kills the brain. In the animals we've studied, the brain is what makes you feel like you're dying. The gut may be what actually does it. But here's the twist that matters for you. In humans, that experiment has effectively never been completed because it can't be. Your brain will not allow it. The micro-sleeps come harder and more often, consuming more and more of your waking time, until consolidated sleep simply takes you. There is no reliable documented case of a healthy person dying purely from staying awake voluntarily. The body wins that argument every single time. There is one terrible exception, and it proves the rule: fatal familial insomnia, an inherited prion disease so rare most doctors will never see it. It destroys the thalamus, the brain structure that generates sleep itself. Patients don't refuse sleep, they lose the machinery for it, and sedatives can't rebuild what's being physically destroyed. It is fatal, typically within a couple of years of onset. But even here, sleeplessness isn't quite the killer. The disease, eating the sleep switch, is eating the body's autonomic controls along with it. For everyone else and for you, the countdown never reaches a lethal number. And that's exactly what makes it dangerous. Because you don't die of staying awake. You die of what you do while you're awake. The driver at hour 20, legally sober and functionally drunk, drifting through a micro-sleep at 70 miles an hour. Official estimates of drowsy driving deaths run into the hundreds per year in the United States. And researchers widely believe the true number is far higher because, unlike alcohol, fatigue leaves no evidence at the scene. History agrees. Fatigue has been named as a contributing factor in some of the worst industrial disasters of the modern era. Remember the blackout scenario, where the danger wasn't the darkness, it was what people did in it? Same rule here. Sleep deprivation doesn't kill you. It arranges for something else too. So, the verdict, could you match the record? Possibly. With supervision, 11 days is survivable. And the teenager who did it recovered after roughly 14 hours of sleep. Not the 80 he'd missed. Sleep debt doesn't get repaid hour for hour. Recovery sleep runs deeper, not longer. Which is also why one long weekend lie-in never quite fixes a brutal week. But 11 days was never the real answer. The real answer is this: at hour 17, you're impaired. At hour 24, your brain is stealing sleep without telling you. By hour 36, the gauge that measures your own condition has failed, and it fails while telling you that you feel great. How long could you survive without sleep? About a day and a half. After that, you're still alive, you're just no longer the one driving, and if a day and a half sounds short, there's a scenario where the entire countdown runs out in minutes, and almost everything you've been told about how it kills you is wrong. Freezing water, that's next.